So you clicked on this video for one of three reasons, I presume. Reason number one, you have some interest in becoming an electrical engineer, or at least some flavor of nerd. Reason number two, you have absolutely no idea what we do, and you're curious. Reason number three, you are an electrical engineer, which begs the question, what are you doing in this corner of the internet? Regardless of which one you are, welcome. And in this video, I'd like to talk about the reality of being an electrical engineer. I myself have been an electrical engineer for the past 2.5 years, and I'd just like to take the time and talk about my general experience of what it took to become one and what I currently do, as well as what led me to become an electrical engineer, and just some advice to someone who might want to be one. I am in no way paid or endorsed to promote electrical engineering, for the record. I just thought this might be an interesting topic to talk about, and it might be entertaining or helpful to somebody. I'll leave timestamps on screen and in the description for those who might want to jump around to certain topics of the video. I understand people with all kinds of experiences and backgrounds might be watching, so feel free to do so. And one last thing before we get started, this kind of video is more atypical than my other videos where I do live commentary, but I thought I'd just try this out. If you guys enjoyed any time, be sure to leave a like, subscribe, it's free, and leave a comment if you enjoy this content or have any burning questions about electrical engineering. But without further ado, let's get into part one. What do electrical engineers do? Well, according to Google, aka AI, electrical engineers design, develop, test, and manage the manufacturing of electrical and electronic equipment, components, and systems. I mean, it's not wrong, but that is the most generic definition I've ever heard. If I had to simply describe it, electrical engineers are people who solve complex problems economically and viably. This goes for any other type of engineering as well. Like, for instance, if everyone had an infinite source of money for all their problems, wouldn't that be great? Then we might just have a bunch of mediocre problem solvers trying thousands of solutions, or just everything would be over-engineered to last forever. The second half of that actually sounds pretty nice, the way we could just buy something once and be done with it. But engineers have to walk the line of making sure something works and lasts, but also making sure it doesn't cost a buttload of money. But what makes it electrical are just the field or areas of study. Areas like power and energy. This involves generation, distribution, renewable energy, grids, substations. And other areas like electronics. This involves microprocessors, semiconductors. I know everyone's heard that a million times with all the AI data centers. Circuit boards, PCBs, which stands for printed circuit boards. So just anything that you see in any devices or appliances. Another area would be telecommunications. This involves telemetry networks, mobile networks, satellites, high-speed internet, radios and antennas. And just another area would be like automation or robotics. This kind of slots under electronics, but more under the premise of programming and developing of automated control systems. So picture all the robot arms moving within like a Tesla factory. And there are far more specific areas, but to keep things short, those are just some of the areas that come to me personally. But now, on to part two, and how I decided to become an electrical engineer and knew it was for me. So the very first and foremost thing that helped me get pointed in the area of engineering was just not being very good at reading and writing. I just never liked reading that much as a kid, and my writing skills have always been terrible. Especially when it came to writing papers that persuades people. Like, if there was a polar opposite me out there, it would be me in sales, where you got to convince people to buy something. But overall, I knew I probably shouldn't head towards a career in general that I was bad at from the start. But where I did excel in school, and this might be a no-brainer for, the title of this video, were in the areas of math and science. I was no bookworm in school, but I definitely enjoyed being able to use formulas and numbers to kind of transform them in ways to understand the world around me. I wasn't always aware of what the formulas or numbers meant, but I always enjoyed the process of understanding them and getting from one formula to the next, or just one stage to the next. I just had a knack for solving problems and the overall satisfaction of coming up with a solution. I also liked understanding how things work, like how does a switch turn on a light, how does a battery store energy, how does a motor spin. I know those are electrical specific, but other things like how does a jack lift a car with a huge amount of force, and how does an air conditioning unit work, and how does a car engine work? I know that sounds really boring for somebody who might be, someone in high school. Those are really boring topics, but I think you get the point. I always liked understanding how things are made and also why they were made in the first place. So that's kind of just where my appreciation of engineering and understanding the world around me. Now, what got me more interested specifically into electrical engineering was when I had to repair my Xbox when I was 13. Now, this was basically doomsday when my Xbox stopped working. But back then, I had the Xbox Slim, and what had happened to it was known as the open disk tray issue. I'm not sure if anybody else had this happen to them, but what essentially happened was the little laser that read the disk of the game when you would pop it into your Xbox would not work at all. The laser typically would move back and forth on two little rails to read the disk, but mine had this problem where it would get stuck in one position. It would think there was no disk in the console. So what I had to do in the interim was rip it apart each time I wanted to play, move the laser back to its original position, and then it would work during that session. But eventually, I got tired of doing that every single time and did some research and found it was best to just replace the whole drive. So I paid the $60 at the time. My dad taught me what little he knew about soldering, and I soldered in a new drive. I then tested the voltages on a multimeter and matched it to the online videos and forums, what they had said, and just like that, I got a very small taste of electrical engineering. Now, I know some people might call that technician work, but the whole process of having to understand the issue, figure out a solution, and do it on my 13-year-old budget, in a sense, is basically what engineering is all about. But now into part 3, the fun stuff. What was the schooling like? Now, to kind of pump the brakes before I jumped on the electrical engineering train, I went to a community college to help save cost, but also narrow down my career decision. I know that's not everyone's route, but at the time, right after high school, I was interested in electrical engineering and meteorology. I know a little contrast there, but both having similar general education classes, so community college was a great way for me to look more into both careers, and during that time I was able to knock out like my calculus 1, 2, and 3, as well as the engineering physics that was required of both. And from what I was told, that my 4-year university was a good idea because it was supposedly a lot harder there. But once I was done with community college, I went to a 4-year university. I really had no expectation for what I was wanting out of a bigger university. I just knew that they should probably be good at engineering. So I just picked one that looked cool and was out of state, just for the sake of not staying in one state all throughout schooling. Not to say you should do the same thing. I was just very low effort back then. So I just did a little bit of Googling, visited the university, and that was good enough for me. I also made sure that a good amount of my credits were transferable. And one great piece of advice that I got from one of my community college professors before I left was, quote, "If you find that a 4-year university is easier than a community college, come see me in 4 years and let me know if I was wrong." And well, I actually did this. 4 years later, I walked into his same office and told him he was right. 4-year university is a lot harder. And then I got to my 4-year university. I still had to take 2 math classes, linear algebra, and the harder one, which was differential equations. If there's any other electrical engineers out there, or engineers in general, that had to take differential equations, let me know what you thought in the comments down below. But then came all the actual electrical engineering classes, which I was most excited for. You start off in a few simple circuits classes, but then you start to get into harder circuit classes. And then you have specific classes like power to systems design, signals and systems, electromagnetism, and then it starts to ramp up into your 3rd and 4th year with even more things like radio and antenna design, power system analysis, embedded systems, energy distribution, and to top it all off, during your senior year, you have a senior design project. And just to take a quick step back, I know not everyone will have the same classes throughout your duration of schooling. For the most part, you will have about 50 to 60% of the same classes, but later down the road, you pick a specific focus which caters to a certain path of classes for you to take, which is typically required for you to graduate. And I know this probably differs from university to university, just as a disclaimer. And just to give some insight about the senior design class, keep in mind this is coming from my perspective at my university, but for a whole year, you and some other students who might be electrical, computer, or software engineers have to pick a project and have to present it to a panel of professors and real-world clients by the end of the school year. This involves hitting deadlines, scheduling work with other students, and making sure what you're working on actually works. Let me tell you this makes you question your sanity some days, but this is to help you prep for the real world. My personal project was for a client that worked with the university for help on his robot, which was used to help bring awareness to students in areas that didn't have a good STEM program. STEM stands for science, technology, engineering, and mathematics. So schools that lacked in those areas, this robot would help teach those kids and teens about those fields. Now, I kind of want to take a little step to the side here and kind of do a part 3.5 about internships. Internships are not fundamental when it comes to becoming an electrical engineer and getting your first job, but they do help as great talking points during your interviews. I know some universities actually require one from what I hear, which is a little crazy to me. I just kind of needed the money and knew it was a good resume builder. As much as it might seem like your experience bagging groceries at a grocery store while dealing with two Karens is admirable, it would be better if you had experience working with other engineers and had a role of responsibility there. I personally had 2 internships during my time as a student. One was unrelated to electrical engineering, where I was working at a manufacturing plant that produced aerosol products. I was under the direction of an industrial engineer where I was improving the timeliness of the manufacturing lines. The other was working at a solar company under an electrical engineer that designed solar arrays. So both were very valuable to me, and I think it had some part to play in landing my first job as an electrical engineer. But the bigger piece of advice to someone applying for their first job, and this could be anywhere, is to talk with confidence and passion. I butchered my first couple interviews, but once I understood why I got rejected the first couple times, I realized I just wasn't doing that. So now on to part 4, the big talking piece. What do I do now? For the past 2.5 years, I've worked as an electrical engineer for a consulting firm that mainly specializes in water and wastewater industries. If you're thinking about poo-poo water, you'd be correct. The firm I work at is multidisciplinary, which means it has multiple kinds of engineers. There are civil engineers, structural engineers, mechanical engineers, electrical engineers, and environmental engineers. To help kind of paint a bigger picture of what I do, I'll quickly describe what these other engineers do. The civil engineers, and we actually call these process engineers, design all the functional processes at these facilities or sites. They design things like the pipes, valves, and gates. They choose what kind of equipment and what size to use within a plant. For example, they might figure out how much water a pump needs to move, or they find out how much oxygen an aeration tank at a wastewater treatment plant might need. Anything that has to do with how a plant works and making sure it works as intended is primarily what they'll do. Then we got the structural engineers, who are also civil engineers, but they have a couple more certifications that make them structural. Their role is to design new buildings or rehabilitate old ones and provide structural support for all the equipment at the facilities. The mechanical engineers will design HVAC and plumbing for the facilities. They typically figure out how much air they need to cool a space or how much air they need to replace for ventilation, as well as designing drainage and sump pumps for the plumbing. Now I know those were some very PowerPoint presentation explanations. Whoa, that was a bar. But they weren't very good explanations, and I might be offending other engineers who might be watching, but hopefully it gives you some sort of background. Now for what the electrical engineers do. For what I do, from an overall perspective, we primarily focus on power and controls at my job. We make sure the power gets to the facility, we make sure all the buildings and equipment have power, and we make sure everything is controlled as intended. Now, to be clear, we are not the ones out in the field who implement this work. We just create the plans, like drawings for someone like a contractor to follow in order to complete the design. We also create specifications, which is like a big document that holds each piece of equipment or material designed on a plan to be held to a certain standard, which the contractor must follow. But just a list of some tasks I do day to day: I size cable and conduit for the equipment at the facilities. I lay out power distribution panels so we can take the cable and conduit and power the said equipment. I typically work with what is considered low voltage, which is under 1000 volts, but I've also dabbled a little into medium voltage design, which is considered 1000 to up to 35,000 volts. For facilities that need some form of redundant power, such as generators, we end up doing the sizing calculations for those. I also design lighting for various types of environments at these plants and facilities. And then for one of the bigger areas I focus in on is we design controls for pieces of equipment, which are typically in the forms of descriptions in the specification documents. I know that's a lot, but essentially what that means is that the contractor can interpret these documents so they know what is required to be built in order for the equipment to work properly. I know that's a very broad statement, but it's like the equivalent of reading how to put together a Lego set. You gather the needed pieces to build the set and put them together step by step. Now, that's not exactly one-to-one here because we leave some of it up to the contractor based off their own means and methods, which is a good way for the contractor to have some more freedom with how they want to get stuff done. While doing all this design, we follow what is known as the NEC, which stands for the National Electric Code. Essentially, it's a handbook that was made to make sure people don't die by getting exploded from electricity or burn their whole house or building down. It's pretty much made for safety and good design, but it's also in place due to tragic happenings in the past caused by bad electrical design or practices. And that's pretty much what I do to an extent. We typically do the same power and control design for clients all over the country, but each client is different, so it keeps the job interesting and makes us think differently each and every day. And now on to the last part, part 5. Should you become an electrical engineer, and what would be my advice? My advice would be, if you have the dream or ambition motivation to become an engineer, I think really anything I say from here on out you don't need to listen to. It's really that simple. But if you're on the fence and there are some things you're trying to figure out to help you make a fundamental decision, here are 4 things I came up with. If you like solving complex problems within a team that helps to better society, if you like having a more fundamental understanding of how the world and things around you work, if you can endure hard schooling for a few years knowing that there are a lot of hurdles and highs and lows to it, and if you have good strengths in science and math and enjoy those areas of study, then I'd say go for it. There ultimately isn't one or multiple right reasons to become an engineer. It all really comes down to who you are and what you enjoy doing. Alright, I know this is a big consideration too, and that is the pay. Engineering in general, from what I know today, is of the highest, if not the highest paying career for a 4-year degree. Keywords there is a 4-year degree. No, you're not getting paid like a doctor or a lawyer, but half or a third of the schooling, you can get a very good paying salary, especially the closer you are to big cities. So if the city life is something you want, that can also be a key factor. But alrighty guys, that's pretty much wraps up what I have to say. I could go on forever and get into the weeds on each area I discussed, but I just wanted to keep things general and give more of an overall perspective. If you guys have any interests in the areas I discussed, or I missed a topic you were looking for, let me know in the comments, as well as any questions you might have about what I discussed in the video. And like I said at the beginning, doing a voiceover isn't my usual style of video, but if you guys liked it, let me know. I'd appreciate the feedback. As well as leaving a like, as it helps support the channel, and if I earned it, feel free to subscribe. Anyways guys, thanks for watching, and I will catch you guys in the next one. Take care. Peace.